Hi, in this section we shall learn about the number system conversions. That is, we have four number systems. From one number system to the another number system we are going to convert the numbers. So let us get into the section, and the first one starts with the decimal to binary. We are much familiar with the decimal numbers that we use in our daily life in the form of numbers, the currency, everything. So, and decimal values are going to be 10 digits, we know, and using these 10 symbols we can form 1 digit value, 2 digit value, 3 digit, and so on. Every position of the digit of a number is going to have a place value. That is, the rightmost bit is going to have the ones place, that is 10 power zeros place. Next one is 10 power 1, tens place. 10 power 2, which is hundreds place. Next is 10 power 3, that is thousands place, and 10,000s place, and so on. So ones, tens, hundreds, thousands, and 10,000s. So these are the place values for the decimal. This part of the numbers need to be converted, translated into binary. So using these binary bits, that is 0 and 1, we need to form the values, and the number in binary would be represented something only in zeros and ones, would look like this, something like this, and these are going to have the place values with ones place, that is 2 power zeros place. Next is 2 power ones place, 2 power 2s, 2 power 3, and 2 power 4, and 2 power 5, and so on. The place values, as the number of digits increases, the place values are going to get increased. So now let us consider one of the example. I have 27 to the base 10. This decimal number needs to be translated into the binary. So I have two methods. Let us go with the method number 1. So for this example, we consider we have 27. 27 lies between 32 and 16, we can see. So 32 is a greater number than 27, so we cannot accommodate it. However, 16 could be taken into consideration, which could be accommodated for us here. So it could take 16 ones are. Okay, so as 16 has been completely accommodated, we place it with 1. In case if we are not considering, we place it with 0. So 16 ones are 16, and we are left with the remainder as 11. The next bit we have it as after 16 we have 8 bit position. So 8 is a greater number than 11. So 8 ones are 8. So we are left with the remainder as 3. Okay. The next bit is going to be 4. But 4 is a larger number than 3. So we cannot accommodate. It's going to be 4 zeros are. So we place that value as 4 zeros are. So 0 is placed over here. The next position is 2. Okay. So we are left with the remainder previously 3. So 2 ones are 2, and we are left with the remainder as 1. And finally we have the bit position 1. So 1 ones are 1, and we are going to be left over with the remainder as 0. We stop the process. So we get the value as 11011. Okay, which we have considered from top to bottom consideration, very important. And these leftmost bits are going to be filled with zeros. Now let us go with the method number 2. That is, the decimal values are going to have base 10, which needs to be translated into base 2 system. So it is better to divide this 27 value with 2. We'll get the respective reminders in zeros and ones. That is going to give us the desired result. That is, 27 is greater number than 2, so it can be divided with 2. That is 2 13s are, and we are left with the remainder as 1. And we'll have to repeat this process unless and until we encounter a value which is less than 2, that is 1 or else 0. So 2 6s are 13, and we are left with the remainder as 1. Next, 2 3s are 6, and we are left with the remainder as 0. 2 1s are 2, and finally we have the remainder as 1. But here we consider the value from bottom to top. So this is how we need to consider. So this is the decimal value, and its respective represented binary value is going to be 11011 to the base 2. Let us go with let us understand much better with another example. Have 86. We shall proceed with the method number 2 itself. So 86 divided with 2. So 2 43s are, remainder is 0. 2 21s are, remainder is 1. And 2 10s, remainder is 1. 2 5s, remainder is 0. 2 2s, the remainder is 1, and 2 1s are, the remainder is going to be 0. So as we need to consider the value from bottom to top, it's going to be 1010110. So this is the respective binary value for 86. So we have understood something good about decimal to binary conversions. Now we shall go with the proceeding of binary to decimal consideration. That is, I want to translate this binary value into this decimal part. Let us look at the section now. So I have a binary value 1010110, that is the previous value we have seen. This one needs to be translated into 86 to the base 10. So these are the bit positions, and every bit position is going to have a place value. That is, in binary it's going to be 2 powers, that is 2 power 0, 2 power 1, 2 power 2, and it continues. So in the conversion from binary to decimal, the bit value and the place value are going to be multiplied. That is, the product of the bit and the place value are going to be taken into consideration, and that product is going to be added to the product of the next bit value and the place value, and this product is going to be added up to the next product of the bit value and position value, and it is continued. So it would look something like this, that is 0 into 1, 1 into 2, 1 into 4, 0 into 8, and it continues. And if you clearly observe, only the bit positions 1, wherever we have the bit position 1, only those values can be considered. The bit 0 values are going to be multiplied, so they give us the result as 0. So it would look like this. So that is 1 we have here, so bit 64, so this is 16, next one is 4, and next one is 2. So 64 plus 16 plus 4 plus 2 is going to give us 86, which is to the base 10, that is the decimal number. So this is how we can translate a binary to decimal. In the next section, we are going to see about octal number system and its respective conversions from decimal to octal, octal to decimal, and octal to binary. Thank you.